Awesome. Thank you so much, Matt, for inviting me, and everyone here for being here. So, um, surprisingly, I'm going to talk about AI today. Probably could have guessed, um, and I'm going to focus in on this idea of data-centric development. So I like the tee up of data being important. It's a common and simple enough sounding idea, but it is, in my view, still underappreciated in what we focus on, both on the commercial and academic sides in AI. So I'll talk a little bit about what the bigger picture, and I'll speak with both my Snorkel hat, and I'm also on faculty at the University of Washington, and then my co-founders over at Stanford, where we started the project. So broader kind of academic community hat, and then also what we're doing at Snorkel, I'll weave in. And the big picture is the role of data development in what it means to do AI development, and how that's increasingly important, increasingly the only interface if you believe the world is going, the world of AI is going where we do, where we think it's going. So I'll start with a perfunctory slide on foundation models, synonymous in the way I'm using it for generative AI models, large language models. I'll get into why I'm calling it that name. But I want to start by very clearly establishing that we are massive optimists when it comes to this technology. My co-founder, Chris Ray, who's a professor over at Stanford, helped co-found the Center for Research on Foundation Models. We've reoriented everything across Stanford, UW, and the company around the last 18 to 24 months on foundation models. We like that term in part because we think they're the building blocks of especially around unstructured data, but really most AI applications. That having been said, we're in a very glorious and exciting hype cycle roller coaster. I actually had a call with one of our customers at a top 3 US bank who paused me on this slide when I was giving an overview. Him and I had talked before, and said he had just made a slide with exactly the same graphic, which I don't know, first Google result for Gartner hype cycle, not too original, and put the dot on exactly the same spot. He might have been being a little generous, but I think it's a N of 1 complete confirmation that this is the enterprise reality. So there you have it. But really, at a high level, we've always kind of thought of these foundation models as incredible first mile technologies. They've existed for a while. I think many of us, myself included, were surprised at the rapidity of gains in performance from back when they were called just pre-trained models and weren't so hypey. But even with this increase in performance, they're still what we think of as, in our view, as a first mile technology. They're really incredible, and sometimes there's not a really difficult last mile to get it to work on a simple application. But in most real-world use cases, and we'll get into how I define that in a bit, there's still a last mile to be traversed. So it's not that they're overhyped per se; they're just not the complete solution. And I think that's something that folks who are working to deploy them in many, if not all, scenarios are kind of coming around to. So how do you actually traverse this last mile? That's one framing of the talk. My marketing lead tells me that last mile might seem too minimizing to the value prop of Snorkel AI. So apologies to customers who or prospects who I'm selling to here. I think most folks here are data scientists. You probably, or at least I think most of our job relies on there being a very difficult last mile and it always being difficult in AI. So I like that term. Anyway, how do you traverse it? At a very high level, the marketing shtick that I've been going with is build GPTU, not GPTX. This is basically the idea that most of these foundation models, like a GPT-4, 5, 6, 7, are going to need to be customized on your specific data and knowledge and workloads. And the key to doing that is data. So I'm going to try to structure this not purely as an intro to Snorkel, although I will, of course, shamelessly weave that in and use it as an example of a data-centric development platform. This is what we build. But I'm going to try to just orient around 3 takeaways that we think are important in terms of how you actually use these tools to build real AI applications that traverse that last mile. Also, I'll pause maybe after. I'll pause intermittently. I know there's going to be 5 minutes at the end for Q&A, but if folks want to bring up points during, more fun that way anyway. I live in California now, but I'm from the East Coast originally, so I'm used to, and I've spent a lot of time in academia, so rude interruptions only make it more fun. Okay, so 3 things. Enterprise data knowledge is the durable moat in AI. I'd argue the only durable one. And we saw this with the deep learning wave, now at the foundation model wave, everything gets flattened at dizzying paces, which is great for the ecosystem. Enterprise data knowledge, meaning data knowledge that is somehow sequestered from the open internet. This could apply to individuals as well, although I'm mostly going to stick with enterprise. Number two, data-centric development, meaning operations around the data, not necessarily the models or algorithms, is the key to actually leveraging this. And one last one at the end, just because we had a paper come out with some UW and Google folks recently that I think is cool, and a lot of usage in industry, which is all about this kind of debate of, is there going to be one big model that everyone uses, or is there going to be a bunch of small specialist models? Things move fast. I may have missed my my moment like a week ago to have that be a controversial topic, but still, I'll give it a shot here. Okay, so point number one, enterprise data knowledge is the durable moat. And if you don't care about enterprise, again, just substitute this in for any kind of private data. Could be your personal data, your personal objectives of what you want to build with AI, right? But it's the input and the output spec. So, again, I'm like weeks, i.e. ages behind in my slide here. But over the last couple of weeks or month or two, we've seen, if you're tracking the nerdy sectors of ML Twitter that I'm on at least, you've seen a flurry of alpaca or sheep or koala themed large language models. The TLDR from all this is that if you take a couple $100 of API calls to, say, ChatGPT, and you graph that onto a model that is substantially smaller, say a 7 billion parameter model like Llama, or now increasingly fully open for commercial use ones like Red Pajamas, one that we're contributing to, and there are many others coming out, you can get very, very similar performance to those kind of closed API models. And that's a fun thing that rolls off the lips. Closed API models like OpenAI, who's right now lobbying in Congress to destroy open source AI. Rolls off the tongue and sounds totally logical, consistent. But anyway, we've seen that basically not only are the model architectures becoming very standard, everyone's using transformer architectures, a bunch of cool new variants that are out of my co-founder's lab, but again, all in the open source. But also the data that kind of trains or aligns or tunes them also can be readily transferred into open source formats. So we're seeing a massive and extraordinarily rapid flattening of the space. Yeah, so I guess I'm kind of veering towards a pitch for open models here. I think the closed models are going to be the ones that are kind of trained for specific usage on specific siloed data sets. So I think the most valuable closed models will be ones that enterprises build either from scratch or on top of some base. Could be a closed source base, could be an open source base. I think if I had to take a bet and hedge a little bit, closed source models like a GPT-4, 5, 6, 7, whatever comes, are going to be very hard to match in terms of generalist capability for, say, consumer use cases that are reflected in the web data they're trained on, and the flywheels that get powered by this mass consumer adoption. But for any kind of specialized use case, they're going to be very readily matched and exceeded when you start using private data and knowledge. That'd be the quick take. And it all comes down to the simple heuristic of follow the data. So we see this evidence that you can really quickly clone these models. There was the Alpaca project. DALL-E out of Databricks is a clone of a cloning project, which is fun. They kind of prove this point, though, that the space is flattening in terms of getting a generic foundation model to build on top of. So then what do you do to build on top of it? Some of you may have seen this Bloomberg GPT paper that came out a while back. And this is a cool example of this idea of a GPTU that is customized on private data sources. This was about 50% public, 50% private data. A little bit behind time, so I'm going to speed up. Again, that's kind of where I think things are going. But they still need to be adapted. There's still a last mile, even if you just kind of throw in your private data. So interesting point is that if you actually open the first page of the Bloomberg GPT paper, the FinServ tasks that it does better on by using private financial data are still getting low 60s in terms of accuracy. So these things are powerful bases, but they need to be built on top of. That's why we like the foundation model metaphor. These things are not just language, so they're not just large language models. They're not just generative AI, also predictive and other classical types should be built on top of them increasingly. But most importantly, I like it because they're foundations. You still need to build the house on top. That's the metaphor. And in particular, I won't spend too much time here, but if you think about two basic axes, these are classical ideas of kind of more bespoke data, so further from the web data that these models were trained on, and higher accuracy bar. That's where these things require more development. So if you've got a very generic kind of problem involving web data, and it's, say, human in the loop, it's a co-pilot for X where it doesn't need to be that accurate because a human's going to correct it, or you may not even be able to measure accuracy. How do you measure the accuracy of marketing copy that you're going to be iterating on that's just supposed to get you started? Then a lot of this out-of-the-box stuff works pretty well and makes for mind-blowing demos. If you're in this upper right quadrant, you have private, complex data. You need to get a really high accuracy before you can ship it. That's where most high-value enterprise AI is, as you could imagine. Then there's a lot of development required. The last mile is significant there. So looking at a couple of use cases that we've worked on with customers, and then one at the end, an open one that we released recently. If you start with just out of the box, so think about a zero-shot approach or prompt, some prompt engineering using those kinds of techniques. Again, this is just a random sample of applications and models, but you often see kind of 40, 50, 60% like that Bloomberg GPT paper. And to actually get into the 80s or 90s, you have to do something involving labeling data. Something, usually this is fine tuning. You can also sometimes shove these into the context window so it gets more complex, but I'll just use fine tuning as a placeholder for that. And you see this in other papers. There's a nice benchmark for ChatGPT that shows on average 25% worse than a specialist model across this big benchmark of tasks. Okay, so how do you actually traverse that last mile? Well, I kind of already hinted that it often comes down to labeling data to make the model better at the particular task. And this is this higher level idea that, tweaking the model, finding a fancier algorithm, all this kind of traditional model-centric development that frankly we still mostly teach in data science 101 courses as what data science is effectively dying off. That's my more dramatically phrased pitch to make this a little bit more interesting. But it's not that much of an exaggeration. When you get, if you believe, and it's not that hard to believe that most of AI is going to be built on top of these large models, multi-hundred billion parameter models, you can't say, oh, it's messing up on this segment of the data, let me go tweak one of those parameters. You effectively have to go back to some kind of data or supervision. And that's what we mean by data-centric development. And this is, I'm going to skip past some of these slides. This is what really went into, going from GPT-3 to ChatGPT, was lots of paid and organic data labeling. One cool study that we just released through some folks at UW and a bunch of others like Stability and Lion and Google and Apple. It's a benchmark, actually. You can go check it out. It's called DataComp. Very excited about this, both because it's a cool open benchmark, but also because it's a nice illustration of this data-centric point. In a nutshell, we took a foundation model called CLIP. It's a image-to-text kind of multimodal model. And we fixed all of the code for training it, the model architecture, the training algorithm, everything, other than the data. And just by cleaning, curating, sampling, filtering the data, we get a new state-of-the-art score at compute parity, beating OpenAI models and others. So it kind of proves the point, not that the other stuff isn't helpful, but it's often not as important as what data you feed in. Sounds intuitive, often vastly underrated because data's messy and we don't want to deal with it, and it's janitorial work that's supposed to be upstream of us. But this is where AI actually gets made or broken. So we view this data development layer as critical. On top of these kind of base LLMs, whether they're GPT-5 or 4 or whatever, or they're an open source base, you have to use this data development layer on top. A lot of this is done manually. A lot of our work over the years, and I'll give a little bit of an illustration just very rapidly about what we do at Snorkel, has been over the last 8 years around A, this bigger idea of data-centric development, and B, trying to make it look more first class and more programmatic like software development, rather than just click, click, click. So that's kind of one of the other key ideas that I guess I did slip in here. It wasn't in my table of contents, but that data-centric AI development just shouldn't be and can't be just, okay, I'm going to get a bunch of people to click one at a time on a data point. It has to be, it also shouldn't be and really can't theoretically just be push a button and solve it. It's a little circular when someone says, well, I'll just use a model to label my data to train my model. That sounds circular. Down to the base theory, it's absolutely circular. You need a human in the loop somewhere, but that human in the loop can be doing something that looks more like software development. whether via code or no code. And that's a lot of what we've done, making data labeling and other data operations programmatic versus manual. So our platform is really, whether you're training, labeling data from scratch to train a model from scratch, as most of our, so you can imagine we work with 5 of the top 10 US banks, number of federal organizations, insurance, pharma, lots of folks who are still working on getting access to foundation models because of heavy regulation and on-prem requirements. So for those folks, we just do labeling data from scratch to train models from scratch. But increasingly, as we move into this foundation model world, what we're doing is we're taking some kind of base model. Again, could be GPT-4, could be an open source model from Hugging Face, or built entirely from scratch in that org. And we're supporting this data-centric loop and making it first class and programmatic, which basically consists of 2 major steps. Find the errors. Where should I actually go in the data to correct where the model's making mistakes, hallucinations, biases, we'll just call them errors. And then how can I correct them? And not just by manually labeling one by one, but also by programmatic forms of feedback. So I'm going to skip through a little bit. Error analysis is extremely important, but I'll skip maybe to this point, which is about programmatic labeling. And the high-level idea here, and I have a lot jammed into this slide, but is that we want to use richer information than just a single label for a single data point. So let's say, I'll give an example from a recent banking customer. We're trying to monitor emails and chats to see if there's something illicit going on in terms of trading activity. Let's just say we want to classify it as yes or no. You can label individual emails as yes, no, yes, no, yes, no, and this is something that they did, and it took them about 2 years to build the data set to train the model that hit their accuracy bar. Or you can say, well, when someone sits down, they have some expertise they're using. We can actually write that down in code. We can say, if I see this kind of pattern, label it yes. If I see this kind of stop word list or match with a dictionary or a legacy system, label no. And that we call a labeling function. And this can be done via Python. We had an open source research project back in the Stanford days that kind of was a demo project for this. It can also be no code. It can even be natural language for non-developers. And it actually subsumes anything that you could jam into a function. So it could be a pattern, look for this key phrase, for example. It could be a prompt. So there's actually a paper we presented recently at iClear on how this technique that's sometimes called weak supervision or programmatic labeling actually subsumes how you manage and orchestrate a whole bunch of different prompts rather than having to pick the right one manually. Could leverage ontologies, knowledge bases, embeddings, other models, really anything that you can jam in. And then under the hood, we use some fun, theoretically grounded algorithmic techniques, sometimes called weak supervision, if you look up the academic papers, to figure out how do I take these kind of functions that are labeling my data that are much more efficient and auditable and adaptable because they're code now, but they're also messier. They make mistakes, they miss data points. How can I kind of clean them all up and put them together automatically? The net result of that is I've now labeled my data. It's usually 10 to 100x times faster, or 10 to 100 times faster. In that case with the bank, we were able to do it in 3 days rather than 2 years. No magic, just sitting down with the subject matter expert saying, okay, why is this flagged? Why is this not flagged? Writing that up as labeling functions, iterating very rapidly rather than waiting weeks at a time to go beg your partner in the line of business to label a bunch of emails by hand begrudgingly, and actually get that out. And then that can be used to either fine-tune your foundation model or distilled into a smaller deployable artifact. And that's the last point I'll leave you with. I'll just leave it as a pointer to a paper that just also came out. This is with another one of my grad students at UW and Google. And it just shows that you can actually, it's just a new technique for an old concept called distillation, but it shows that you can take these massive kind of generalist foundation models, and not only can you tune them using that kind of programmatic labeling to be more accurate on a given task that you need to be really accurate on, but you can then distill down very rapidly to a specialist model that's not only more accurate, but hundreds of thousands of times smaller. So that's the last kind of prognostication or bet that I'll leave you with, which is that it's there are going to be these base models. They're probably going to be increasingly open source, and then the reality of what actually ships in production is going to be a whole kind of family tree of smaller specialized models that are tuned and adapted via data-centric AI. And if any of that sounds interesting and you have problems, this seems relevant, would also love to chat, of course. I'll speed answer. But thank you all so much for the time to listen to this.
Hi, I found fascinating that you centered the conversation around the accuracy of the model on the data labeling. But if you're automating the process of the data labeling, how, like, doesn't that become also kind of a loop? In the sense, like, how do you monitor that those labels are flexible, and a bit, like, how do you disrupt the educational system for the model? If you're constantly labeling it and you're creating norms for it, at one point those norms are going to be crowding the model itself, right? Or is that?
Yeah, so let me try to answer in two quick pieces. So one, and we can talk afterwards too. One is, generally when you're doing this programmatic labeling, and this is this kind of middle picture, you're just labeling some of the data. So maybe you label 20, 30%, whatever, I'm picking a random number. You then use a model to do what machine learning is supposed to do, which is generalize to the full data set and new unseen data. The second thing about propagation is that absolutely how you write these labeling functions, biases, errors, et cetera, will absolutely propagate directly to the model. But you now have a much more adaptable and auditable asset, right? When your data is being labeled by a code asset versus a pile of outsourced annotator labels, you can actually correct those biases. I once had a 3-star general come by the lab in the early days of the project growling about schema lock-in. He just spent 10 million on data labeling for aerial imagery, and then the mission objectives changed, and he realized he had to throw it out and start over again. So it's both auditability and debiasing, but it's also just change, right? Something that many of you may have run into is, hey, if you spend a lot of time labeling data or begging your colleagues to label data or outsourcing it, and then anything changes, the output schema, the input data, you're often starting from square one. So this paradigm is not perfect, but it just makes it look more like software development. Something changes, you just go and update the code and recompile. And that's kind of even the more important vision than it being faster to start. It's better maintainability. So anyway, thank you all so much. And Matt, thanks
Alex.
for having me.
Super great.